So now we're moving into performing the second part of today's exercise, where we're going to be performing the same titration you just performed for part one, but this time applying it to 3 commercially available juices. The first juice we'll be testing is orange juice, and again we're titrating orange juice with a certain volume of iodine to determine the amount of vitamin C present in 10 mils of orange juice. So I went ahead and I added the 20 drops of my indicator, the 1% starch. That's equivalent to 1 mil of the starch, giving my solution a quick swirl to make sure the starch mixes nicely with the orange juice. And I'm going to go ahead and start the titration reaction. So you can see already we're starting to see some color change. That doesn't mean you stop. You have to keep going until the entire solution has changed color from what it was. So that looks pretty good to me. Now bear in mind that whenever you're doing a titration reaction and you're depending on a change in color to show you when to stop, you'll reach a point where you're adding your titrate and then the color will change very briefly and then it'll go back to what it was. You want to push forward and make sure that the color change is permanent like it is here. And so the original color of the orange juice was a nice bright yellow, but now it looks like it's some type of dull brown solution. And so in my opinion, this is enough of a color change to stop the reaction without overshooting or going past the endpoint. The next thing here is we need to go up top and check out how much iodine was used. So if you guys recall, we started at 0 at the very top, or 50 mils. And right now it looks like we've used approximately 15 and a half, roughly 15 and a half mils of iodine. That's it. So now we're going to move on to testing our second juice, which is lemon juice. And I went ahead and I added my 20 drops of my 1% starch indicator, giving the flask a nice swirl to make sure the juice is mixed nicely with the starch. Now I'm going to go ahead and open the stopcock and start titration reaction. And so I'm going to temporarily close it to make sure I don't overshoot my endpoint. The thing here with lemon juice is you guys perhaps can hypothesize that lemon juice is very sour. Chances are it has a lot of vitamin C in it, and so we have to be very careful when performing the titration of this particular sample. So I didn't even have to run the titration for that long, and the color already started to change. So here we're going to slow things down a bit and make sure we don't overshoot the endpoint. So this is a nice color change. Just so you guys can convince yourself that a color change did occur. We started out with a bright yellow solution and now we have something that is purple or blue-black. And so let's see here, we started at about a full column, 50 mils, and so we went through 1 mil of iodine to titrate 10 mils of lemon juice. So the before would be 50 mils, the after would be 49 mils left behind. Taking the difference would account for the 1 mil used for this titration. So we're moving on to titrating our last sample of juice, and this is going to be apple juice. I went ahead and I added my 1 mil of my starch indicator to the solution, giving the flask a nice swirl to make sure that the juice has mixed with my starch. Now, I'm going to go ahead and start the titration reaction. Let me just borrow this piece of paper over here so I can know when to stop. Alright, so I'm opening the stopcock and the iodine is flowing through. So you might be asking yourselves, well, the reaction proceeded very quickly for lemon juice. The reaction proceeded relatively quickly for orange juice, but with apple juice, does apple juice even have that much vitamin C? If we were to rank the rates of the reaction for all 3 juices tested, where would apple juice fall on that spectrum? So let's take a look. Okay, we're starting to see a little color change, not much. So it looks like I'm going to have to top myself up with another 50 mils of iodine. I'm just going to wait till I'm completely finished with this aliquot. Alright, so I'm going to close my stopcock and I'm going to add some more iodine. And of course, technically you want to take this down and you want to have it at eye level so you don't splash yourself, but I'm a pretty tall guy, so I'm just going to leave things as is. It's close enough, I don't want to risk going over too much. Now let's finish the titration of this apple juice. Alright, the blue color is becoming more and more persistent. And here we go. We're finished. And then there you go. There's your titration of apple juice. Beautiful deep blue color. So because of the fact that we had to add two 50 ml aliquots to the burette to perform this titration, the initial volume will of course be out of 100 mils. And so we used a full 50 mils for the first round, and then we used 14 mils for the second round. So that means in total, we used 64 mils of iodine to titrate our apple juice sample. And now for a discussion of the calculations for part 2, I'm going to turn things over to instructor Krista.
So now we're going to be discussing the calculations for part 2. We're going to start with orange juice. We've completed all trials for orange juice, apple juice, and lemon juice, and we're going to start first explaining the data for orange juice. So for each trial for orange juice, we used 10 milliliters of juice and we added the starch, as you guys saw. For trial 1, our initial burette reading was 50 milliliters. Our final burette reading above here was 34.5 milliliters. And that means that the amount of iodine that we used was 15.5 milliliters. Our next step is to now determine the milligrams of ascorbic acid in the titrated sample, so in our aliquot of orange juice. To do that, we're going to be taking the amount of iodine that we use to reach our endpoint, which in the case of trial 1 is 15.5 milliliters, and multiply it by the average milligrams of ascorbic acid per milliliter of iodine that we got from part 1. And to remind you, that value was 0.19 milligrams per milliliter. So when we do this math, we see that the milliliter units cancel out so that we're left with milligrams, and our final answer is 2.945 milligrams. Moving on to trial 2, our initial burette reading was 50 milliliters. Our final burette reading was 39 milliliters, and that means that the amount of iodine solution that we used to hit our endpoint was 11 milliliters. Now we're going to determine the milligrams of ascorbic acid in the titrated sample. We're going to take the amount of iodine that we used, 11 milliliters, and multiply it by the average milligrams of ascorbic acid per milliliter of iodine that we determined in part 1, which is 0.19 milligrams per milliliter, following through with the math, we see again milliliters cancel out and we're left with 2.09 milligrams of ascorbic acid. So now we're going to move on to these last two entries in the table here. We want to now determine the milligrams of ascorbic acid in 100 milliliters of juice. So to do that, for trial 1, we're going to take this number here, 2.945 milligrams, and multiply it by 100. And that gives us a value of 294.5 milligrams of ascorbic acid in 100 milliliters of orange juice, hypothetically for trial 1. Moving over to trial 2, we're going to take 2.09 milligrams of ascorbic acid and multiply that number by 100. And we get 209 milligrams of ascorbic acid in 100 milliliters of orange juice for trial 2. The last thing that we have to do is take these two numbers, 294.5 and 209, add them together and divide the answer by 2 to get an average, and we're left with 251.75 milligrams per milliliter according to these calculations. Now we're going to be moving on to our apple juice. The idea for the calculations it's essentially the same, but we'll still run through them briefly. So for apple juice, our initial burette reading was 100 milliliters. We needed to fill up the burette twice. So that's why the initial reading is 100 milliliters here. Our final reading was 36 milliliters. So that means that we use a total of 64 milliliters of iodine for trial 1. Now we're moving on to the milligrams of ascorbic acid in the titrated sample. We're going to take 64 milliliters and multiply it by 0.19 milligrams per milliliter. Again, that's that average value that we got at the end of table 1 in part 1. Doing this math, we get 12.16 milligrams. And now moving on to trial 2, our initial burette reading was 100 milliliters. Our final was 30 milliliters. That means that we use a total of 70 milliliters of iodine solution. Now we're going to determine the milligrams of ascorbic acid in the titrated sample. We're going to take 70 milliliters and multiply it by 0.19 milligrams per milliliters, and doing that gives us 13.3 milligrams of ascorbic acid. Now we're going to move down here to these two entries. Our next step is to determine the milligrams of ascorbic acid in 100 milliliters of apple juice. So we're going to be taking for trial 1, 12.16 milligrams and multiplying by 100 to give us 1,216 milligrams of ascorbic acid. For trial 2, we're going to be taking 13.3 milligrams and multiplying it by 100 to give us 1,330 milligrams of ascorbic acid for trial 2. Our last step is to find the average of these two numbers. When we add them together and divide by 2, we get 1,273 milligrams of vitamin C per milliliter. Lastly, we're going to move on to our data for lemon juice. Again, the idea behind the calculations is the same, but we're going to run through it. For lemon juice, for trial 1, our initial burette reading was 50 milliliters, and our final was 49 milliliters. So this titration, reaching the endpoint, happened fairly quickly. Doing the math, that means that we used a total of 1 milliliter of iodine. Our next step is to determine the milligrams of ascorbic acid in the titrated sample. We're going to be taking 1 milliliter and multiplying it by 0.19 milligrams per milliliter. Again, the number is coming from part 1, the very last entry in the table for part 1. Doing this math, we get 0.19 milligrams of ascorbic acid. Now moving on to trial 2, we have an initial burette reading of 50 milliliters and a final burette reading of 48 milliliters, meaning that we use 2 milliliters of iodine to reach the end point of our titration. Then we're going to be taking the 2 milliliters and multiplying it by 0.19 milligrams per milliliter to leave us with 0.38 milligrams. Now we're moving on to these last two entries in the table here. Our next step is to determine the milligrams of ascorbic acid in 100 milliliters of lemon juice. So we're going to be taking 0.19 milligrams for trial 1, multiplying it by 100, and we get 19 milligrams. We're going to do the same thing for trial 2, and we're going to be taking 0.38 milligrams and multiplying it by 100 to get 38 milligrams. Our very last step is to find the average of these two numbers, so we're going to be adding 19 milligrams plus 38 milligrams and dividing it by 2, and that'll leave us with 28.5 milligrams per milliliter.